All right. Looks like we got about 40 responses in there. So some of us working again. It's not a big deal. We'll send this out if you don't have access to these things. Uh, that's for the other class. Just a reminder, those of you that get Kansas CEOs, there's additional paper form that you have to fill out. There's a spot on this sign-in sheet to leave your email address in that section. Please make sure you do that. If you got one group one and that's where you want them to all go, that's fantastic. But you got to do that. And Craig Duty handles Kansas credits, and he has a deadline. So you got to get on that, and you got to get that to him as soon as possible. Once we get past that 30-day mark, you can't submit them anymore, and that's a Kansas rule, not a Comfort Products rule. So no big changes here. Still have the four of us that's handling this, and I apologize to Rob. Looks like I spelled his name wrong. It's Roche. And then of course Ben, and we're always looking for that fifth guy or girl. So think about it. Changes to tech support. I know we're all sick of changes probably, and it is what it is. So the number is still active. You do have to have a 6-digit code to get to us live. However, the other methods, you don't need any special way. You got an issue, you send us an email to that email you saw. There it is again. If you're a texter, we like texters, send us a text message. The submission link that you saw on the website, you can always get that link and put it on your phone and just keep it as a shortcut on your phone, and then you're right there and done. No, you do not have to finish the test right after class. You can complete it later, but again, the sooner the better. Once I think all the tests are done, I'm going to start doing reports, and once I submit that stuff, it's done. So sooner you do it, the better. Yeah, okay, so option 4, and then option 5, again, we showed the tech support tab on the website that I showed you. Biggest thing is, and this happens a lot, and I get it. I was a technician for many years. Craig was a technician for many years. So, but hanging up and calling back and hanging up and calling back, it's not going to help you. Trust me, if you leave us a voicemail, you have a code, we get it. If you send us an email or a text, we get it. Nobody gets left behind here. Okay. Just depends on how busy we are, is how fast we get to you. So it's a thing that happens. If you leave me 5 voicemails, you're still only going to get 1 phone call back. So just trust that we're going to get back to you. I don't know anyone that we have never ever gotten back to. There's been a few guys that maybe it took a little longer than we would have liked and you liked, but we get back to you. Biggest thing on those messages or the text messages or the emails, got to have that model and serial number. Very important that I know what company, or not just me, but we know what company you're working for. If you know your account number, fantastic. If you don't, that's fine. Your company name is fantastic. Who you are, right? And a phone number and a description of the problem. For instance, you can't say it's Joe. I got an issue with air conditioner. Call me back. We don't know what kind of air conditioner, right? You don't know if you're on a commercial unit. You don't know any of that. So as we go down a little further, I'll show you why that's important. And I know in the past it was just, hey, call me, and we called you. But we're trying to improve things here, trying to put guys on different units and different products, and we'll show that later. So it's really important to leave that information. Especially the texters, if you're on site, take a picture and send it. It's fantastic, right? So, and that's the best thing about that text service, is that's the best way to get us pictures in the fastest way, because the text picture comes a lot faster than an email. So class today, we're going to talk about, as briefly as I can, as we go through the class today, if you have questions, the chat box is the best way to send me a question. Unfortunately, we use the webinar, so we don't have to play that, hey, mute your phone, hey, do this kind of thing. So this webinar works great, so we don't have that distraction. Send your questions that way. We're talking about troubleshooting some common parts. We're going to go through economizers, and I'll breeze through some of it. But again, those of you that have questions, and I get a lot of calls, so I know you have questions. Low ambient controls, everybody's favorite VFD drives. Very brief on the EcoBlue because we've hit that several times. I don't think we'll do tools. I think you guys know that by that point, other than make sure for the principals here, make sure all your techs have a manometer. There's so many times we ask for airflow and they don't have it to give us. And then a little bit in error code identification. So again, the model number tells us a lot. It seems like just long drawn out number, but every one of these spaces in this 18-digit model number, one, it tells us what type of unit, it tells us what the voltage of the unit is, what components it may or may not have. So we don't have to waste time gathering that info. You've already given me the model number, and I can see, okay, this is a unit that definitely has this type of economizer, this type of a control box or whatever. And then a lot of times I can answer your questions faster, or the group can. And that just doesn't go for commercial. That goes for everything that comes out Carrier, Bryant, Payne. All right. So that's why we need that information. Just remember, when it comes to commercial units, at 25 ton is our cutoff. There is another division of Carrier that takes care of anything larger than that from us. They take care of all of all the chiller questions for you. Now, if you need parts, you can call the part counter, they can get it. But there had to be a cutoff somewhere. So long before I got here, they cut it off at 25 ton. And then you can call, and there's 877-963-1995 phone number that you can call for support with anything above 25 ton. And of course, the numbers in front of the tonnage here is the model number. So it would be a 48, whatever, HCTE 28. So it means you got a 25 ton unit. And again, here I talked about that. So you can see that every digit there has a purpose. The biggest one we look for, obviously, is the size. So 7 and 8 tells us what size you're working on. Then the other one we look at is number 14. So what kind of controls are you using? You know, is it a building management system, or just doing some sort of thermostat control? And then, of course, the power that you have. What's your voltage? Are you 208, 460, 3-phase, whatever? So that's where that comes in. It just saves a lot of time, so we don't have to get into all that. So here's why we're kind of a stickler to the model number and having that information beforehand, because everybody is assigned a product line, for lack of a better way. So right now, I think this is starting October 1, so starting Friday. Rob's going to handle furnaces, fan coils, and BAP coils. Craig is going to be our ductless guy, geothermal, IAQ stuff. Ben's going to handle heat pumps, ACs, any of the non-communicating thermostats. I handle commercial equipment and zoning. And then, of course, the oddball stuff will all sign in. So if you're calling about an Infinity or Evolution control, you may get one of the 4 of us. But we had it a little different way, and it didn't really even out as much as we had hoped. So again, we try and do that. And of course, the office field day stuff is just for us. You don't have to worry about that. Serial number breakdowns. You know, again, this is important mainly for us. One, it's going to tell us how old it is, or at least when it was made. You know, sometimes even though it's an 04, it may not have been put in the 5 or 6, and that's fine. We can verify that. You know, as far as Carrier goes, they're looking at which plant did it come from, especially with issues. So they love to have that. And so that's why those things are super important. You know, the name and company and that kind of stuff comes into our record keeping, because once we put it into our data system, as far as we log your call, what we've talked about, what equipment we worked on, it's a research thing for CE and for us. Because if you call back, hey, we have a whole bunch of info, we don't have to ask all that craziness again. So, you know, it's new. Some guys have adapted it. Some folks, you know, are taking a little longer. But you've probably noticed that if we don't get some of that information, the first thing we're going to try and find out from you is those basic things. And then we're going to let you ask a question. It eliminates some of that time that we're on the phone, and it eliminates, you know, some of those delays. So the sooner you get that stuff to us, we're here to answer your question, help you out as best we can, and we roll on. All right. All right, troubleshooting parts. Some common parts. Oops, well, we'll just leave it there. Any kind of central terminal board, main terminal board, defrost board, obviously, right? That's a big one on a commercial unit. The IGC, the ignition control board, is a big one. That model legend is in all install manuals and product data. So, I mean, I certainly can send it out, but any of your paperwork you get with a unit, especially commercial units, you're going to have that right there. It's hit or miss whether it's install or product data. Newer units, it seems to be install. Older things, it seems to be product data. And that's right in that tab that I showed you on the website. It's where we had the product manuals. Bang, it's right there. You can print that off. But yeah, I'm happy to send that out if anybody needs it. Just contact me later and I'll send you one. Ignition control board, Hall effect sensors, which are still out there, but kind of a past thing. All right, so, you know, a central terminal board. This it's obviously a little older version, but I couldn't find a really good picture of the new one that I liked, so I just kind of stuck with this one. So obviously when you guys get it, there's a whole bunch of wiring hooked up to this, and unless you're replacing one, you get it this way. But you know, everything here has a purpose. You know, you can see where the economizer ties in, your outdoor stats, thermistors if you're using it. If you're doing any kind of building management control, you know, that's where DDC comes in. Control board, which is your main bus. If we're dealing with any kind of reheat or a heat pump, you got a Molex for that there. Occupancy cutoffs. Then of course, low and high pressure switches for both circuits if it's a two-stage or anything in that line. So really basic wiring data here. So that's basically just the board. And something to think about for you guys when you're talking to us, you're looking at a board, we're looking at this. So that's where some of that, well, hey, why don't you find the control board Molex, right? And depending on the orientation of the board, it gets a little weird. So, you know, we're obviously not trying to be hard about it, but that's what we're looking at. We don't rarely get to see pictures of the boards. Now, thankfully, to the tech site, you know, you can send me a picture and then I can see what you're looking at. And then there's things coming that we can do a lot more FaceTime and those type of things to help out as well, which it's coming soon. I just can't tell you when. So just basic wiring diagram here. You can see this one shows everything with a Molex, and that's just a central terminal board or the main board. Obviously, most of the new ones are blue now. So for breaking this down, obviously that thermostat strip there, no rocket science there. We've seen those for years. So that's where our thermostat ties into. If we're dealing with some sort of building management, R2 open, BACnet, something or else, again, that's where DDC comes in. So basically, unless you have that, there might be a Molex tied in there, but it's just left hanging. Reheat board will have a Molex that goes to that board if we need it. Again, The main control board, Molex, for this is a gas unit, so that's going to go to the gas IGC board. Phase monitor if it needs, compressor terminal, fire and smoke shutdowns. Again, if we need them, and you can see there's jumpers to cut if you're wiring any of those up. And then of course, low and high pressure switches. So again, just some connections here on that economizer pin, that 10-pin wire that typically goes out to the economizer. You know, if you don't have one, you got a jumper plug in there and it's no big deal. If you have one, then of course it's wired in there. So the biggest thing to remember is about that cooling. That cooling call comes from a thermostat, but it hits your economizer first before it gets anywhere. And we'll talk about that a little more in detail because that seems to confuse some folks. But there's an output to it, which is from the thermostat, then it returns from the economizer, and then it starts to hit the contactor or the pressure switches or whatever's going on there. So the biggest thing to remember there is terminals 1 through 4, you know, that they are used in cooling operation. So that's hint, hint, test question, that what are those 4 used for? All right. And why is it important for you to know that? SAT, OAT, pretty simple. That's just where your sensors tie in. Heat pump or reheat control, again, that's the output here. Indoor fan signal, there's a return. So in most of these, there's always a supply and return. Again, Y1 from economizer, compressor 1 signal. So everything is back and forth. So when you're talking troubleshooting, and we're going to talk a lot about the path of these signals to try and help guys diagnose these things while you're on the roof. 12-pin control board connection. Again, now you got your W2, your W1, indoor fan controls. It's where your transformer ties in to power everything. Indoor fan overload in and out. So, you know, all of them have a fan overload. Some of them used to be a smaller switch. If we talk vane axle, we got that stator limit, but that's where that ties into. So again, when we're talking the path, these are a couple things that we're checking. All right, do you have power here or do you want? And this is why we're doing that. The compressor lockout board that they label CLO. This seems to really perplex folks. It's actually just very simple. It's really just a relay board. So when we get that Y1 signal back from the economizer, the first thing it hits is terminal 4. So it comes right from the economizer. It goes through the board. There's a couple jumpers. As long as they're intact, it goes right to terminal 4. Then it jumps to 5 when there's a little jumper wire on the board. 5 at that point will send it through high pressure, low pressure. And again, we'll hit this again. And then as long as all that's satisfied, it comes back to 6. 6 sends it to the contactor. So if you think your CLO may be bad, the easiest way to test this is to jump 4 to 6. If the contactor comes on, then you got something, a bad switch, a bad high pressure or something. Super simple to diagnose those. The only difference in a 2-stage is you'll have that second CLO, and then that has a terminal 7, which sends a signal to ramp up the outdoor fans. Your phase monitor relay, if you have one of those, basically just an input output situation. If it monitors something doesn't seem right, then of course that's a shutdown spot. Your digital control, that's where your smoke alarm output, if you're using DDCs, if you have AccuSensors, outdoor sensors, supply air sensors. So that's part of that wiring for those thermistors. Pretty simple there, right? Digital control thermostat. So it's just your thermostat connections. Common. I don't usually use X much. That's just if you have an alarm set up. If somebody wants to flash a light, unit's not working or whatever. G, W2, W1, Y2, Y1. And we'll talk about it later, but you notice there's no O here. So we don't worry about reversing valve control. Safeties in all the units. You can have an occupancy switch if you want. You know, you can wire it up as a switch or have a control or whatever. That's there. High pressure, low pressure. If it's a two-stage, obviously you're going to have two sets of those. Field accessory connections. Again, here, this is where we're talking about smoke detectors, external safety shutdowns, you know, whatever you got on your unit, the ability to control that and shut down the unit for safety is there. All right. Any questions so far? All right, rolling on. So we talked about those jumpers. Obviously, the board is going to come with all of those intact, and you have to have to know what's cut, what's not cut. Obviously, it's nice to know why it's not cut. The jumper one there on your right, obviously, we're talking if we have a phase monitor, we're going to cut that because obviously we're sending power out of the board. So if we don't, we're blowing 24-volt fuse. Occupancy control is in the center there if there's some need for that. X terminal was it's kind of an old picture. It was an old common, like an extra common sort of thing. You won't see it on anything modern. And I doubt you'll ever see it wired up. Jumper 4 there, remote shutdown. You know, if there's some sort of, they need a button or a switch to shut everything down, you can wire that in and break that connection. And then of course, jumpers 5, 6, and 7 is if you're using reheat or heat pump, and this is going to come from the factory already cut. But again, if you're changing a board, you're going to have to remember to cut those. So those are there for that. And we talked about this. Jumper 1 is the phase monitor accessory. Jumper 2 is occupancy. Removes power to the countermeasure control, so then everything shuts down on the occupancy. Phase monitor, again, will remove power if it notices something's going on. Smoke detector, again, immediate shutdown if the smoke detector activates. And they're all different, right? Some are normally open, some are normally closed. It's just going to depend on what you put it in there. Takes power from R because that's right in that initial 24-volt path. So if that's open, excuse me, you're not going to see power between R and C on your terminal strip because it already cut it before it even got there. And that's the last spot that the transformer power hits. So it runs through all of this stuff first. Same for remote shutdown. It's going to immediately terminate shutdown. So jumpers 5, again, opens Y1, allows reheat control board to send signal to CLO controlling the compressor. So that's why we cut those if we're using that. Jumper 6 has to do with the fan, indoor fan motor, signal and return. And then jumper 7 is just the second stage of that. So I talked about that path and troubleshooting these outdoor units. So right now, obviously, we're looking at low voltage and it's in standby, so it's just kind of sitting there waiting. So here's your transformer leads coming in. Yes, Don. Okay, awesome. Thank you. All right. So the transformer obviously comes in and hits terminal 9 there, and then it's distributed. So again, first thing 9 comes in 9. It's going to run through 10, come back 11, go through occupancy. It's going to jump that phase monitor thing there where it says jump 1. And then it's going to start to go through remote shutdown, smoke shutdown. So it runs through that whole path first, hits that, hits here, there, and then finally at your thermostat. So if you lose, if the fan switch is open, or if remote shutdown is open, or a smoke shutdown opens for some reason, there's an issue, you're never going to get power here. And I know it's one of those things that the first thing everybody wants to test is they want to check RNC, and I get the phone calls, hey, I'm on a rooftop, I don't have powered RNC, but we've never checked the path that goes through. So start to look that and follow that. You got to see it here, and you got to work its whole way, because that's the last thing it powers. All right, so fan operation. Obviously G, if we're just running the fan, we get 24 volts to G. We're going to look and make sure that jumper is intact. We can undo that if we got some sort of relay or something that we're in there. So yeah, Mike, I'm gonna send this out as a PDF once we're all done. So email me later just so I remember, if you would, please. Sorry, I lost my track. So obviously we're gonna, if that's intact, then it's gonna hit the indoor fan contactor. And then again, it's going to start looking, make sure occupancy is not used if there's a jumper there. And then we're going to look down here, depending on if there's an economizer, no economizer, no big deal. And then off it goes. So if you have it, obviously then it's going to send that to minimum position. It's because we're running the fan, right? So, but if you don't, then it just dies there and the fan runs. So first stage cooling. So obviously we're going to get 24 volts to Y1. Then it's going to run through the economizer. If you don't have one, it just got that bypass plug in there. And then it's going to jump from, comes in a blue wire, comes out a gray. Again, looks to make sure that jumper's intact. Goes over to number 4, like I talked about, jumps to 5, runs through high pressure, low pressure. If they're satisfied, hits 6, contactors engaged. So if you have power through all that, then what's the most logical thing, right? There's a possibility of a bad contactor. Because we have power all the way up to there, we're only leaving the one thing left. So second stage cooling, exact same process, 24 volts to Y2, goes down to the economizer, comes in the yellow wire, goes out in orange. Looks to see if that jumper's cut or not. Do we have reheat board? Do we have whatever's going on? It's intact. Goes over, hits number 4 again on that CLO, 5 through the switches, back to 6. And it also energizes 7, saying, hey, I got a second stage call. I need more outdoor fan. Right there, need more outdoor fan. Off we go. So the path of power is exactly the same, right? Now, if we're talking heating, we're going to get that W1 call. Now, this is obviously a heat pump system. So it's going to look for that electric heat contactor. It's going to energize that for W1. And then obviously we're going to get the same thing. We're going to get the fan, we're going to get W1, and then off we go. If it's a heat pump, so we're going to get that W1 call down through the economizer again, same exact path, looking for jumper 5 because we're talking about W1 or Y1. But at that point, now it's going over to your eHeat board. And then this board is going to start to take control of what's going on here. So the frost board gets a Y1 input, compressor one, RV1 outputs are made down here. Looks to make sure the freeze protection status closed. Checks the high and low pressure switches. And then off we go. And of course, also the fan, that jumper 6 is going to be cut. The board now controls the fan instead of it getting a direct call through the main board. Gas heating. Same thing, W1. Now at that point, it goes to the IGC, which is now, this takes control. Looks for gas valves. Says, yep, I got a W1 call. I need a gas valve. And then again, IGC signal to IGC, it takes control of the indoor fan. So if you're trying to test this and you're trying to jump things out in heating, the sequence is different from what most residential guys are used to. So that's where some people get confused. Hey, I'm jumping G and I'm not getting a fan. It really depends on what unit you have, whether that will work or not. All right. So I breezed through that fairly quickly. Any questions? Awesome. All right. So just kind of showing a few boards here. 05 thermostat demands, first, second stage cooling, second stage heat, emergency heating, defrost controls in heating mode. So most of the defrost boards do have a forced defrost on them. Some of the really new stuff doesn't, but most of them have that. So you'll see that same basic thing, right? We got the pins. You got a defrost thermostat or a thermistor somewhere that's monitoring temperature, telling it when to do it. Same basic operation as the residential units, depending on what your pins are set for. That's how long it's going to wait to defrost, right? That's the huge thing. Doesn't mean it's going to do it for 30 minutes. It just means it's going to wait to check if it needs it for 30 minutes. So depending on what you got going on there, most guys do that backwards. If they want more, they try and set it for 120 and they're going backwards. So same thing on a commercial unit as a residential unit. Yeah, that's what we talked about. Heat run time, factory 60 minutes. Just means it's going to run that long until it looks to defrost. Terminates when the DFT rises, or if it ran for 10 minutes. Obviously, if we're not defrosting long enough and we're defaulting out, then we got another problem, right? Do we need low ambient here? Do we need, what's going on? Because that's a problem. But yeah, typically those defrost settings are they close at 30, open at 80. Again, sometimes there's a differentiation there between what unit and how new or old it is, but that's a pretty average amount. So that board, this is off a 38 AUQ defrost board. It's kind of your in and outs on some of those. Obviously GFan is a D1 input, so it's just 24 volts. R power, ground, defrost switch is a 24 volt switch, and any defrost switch can be jumped out. It's just a switch, right? So if you're not sure, jump it out and see what happens. Outputs, inputs, configurations. I think I'm going to spend a whole lot of time in there. And then the speed up jumper on some of these. So basic wiring here. Again, just remember that once we add something here like a defrost board or an IGC, it starts to take over control of the unit in select modes. And a lot of times it really just takes over the fan. When the fan comes on, when it goes off, it starts to operate that to where other units, the main board does it. Big thing here is, I talked about that a little bit, no O on a commercial unit. The board takes care of that, all right? Oops, so No O or B signal required. You know, B is the old way where it was that Rain used to send a B because they energized in cooling where everybody else energized in heating. This is energized in cooling. So again, that's backwards from what most residential guys see and gets them confused. The reversing valve does not shift mode in the off cycle. So if we're in heating, it stays in heating until it gets a cooling call. So you won't see it equalize. That's a big difference with commercial units. High pressure switches, majority of them open at over 600, close around 5. Liquid line, you know, opens at 27. That's the loss of charge one, closes at 44. Obviously, you know, if that one's open, you got a big problem, right? Freeze protection opens at 30, closes at 45. So it does wait till it gets a little past what we consider freezing before it closes or opens, forgive me. And that connects on the defrost board. All right. Questions? Pretty simple stuff. Talk about the IGC board now. Now that part number has changed, and I apologize, I didn't have time to change it, but the board stayed the same. So this is your ignition control board, timed off control for the indoor fan. So again, once we're talking heating, it takes care of the fan. It's going to do that delay, let that heat exchanger heat up a little bit so we don't get much of a cold blow. Burner ignition, flame sensing, all done through the board. Monitors safety devices the whole time. So even though you're running for a bit and then maybe that flame sensor loses it, that way it's going to shut down. So it watches that constantly. It's not just a startup like some of the old boards used to be. Obviously, and then of course air codes, right? We're going to have that little blinky light on this one. It's going to tell us at least what sort of kind of happened. So again, there's your LED status light, induced draft outputs there, indoor blower output. Talked a little bit about Hall effect sensor. It's thankfully they're sort of a thing in the past, but you're still going to run into them depending on how much commercial work you do. There's your low voltage harness, which everything ties right to the main board. It does have a 5 amp fuse. Obviously, most don't have a spark generator anymore, but some do. They're still out there. So this part hasn't changed. Even with the newer boards, the flashes are the same. If you're looking at it and it's on, basic, normal, just sitting there waiting, right? It's in wait mode. If it's off, we've either lost power or we got a problem with the board, right? So again, we're going to make sure if it has power, and then we'll move on and start looking for something else. One of the limit switches open. Remember, on the heat side, not the refrigerant side. You're going to get 2 flashes. If it lost flame, you're going to get 3. And then again, there's those lockouts. If the limits went 4 times, you know, if it restarted, and kept going out, that's when some of that changes. You're going to get a lockout. Maybe you get a 6, that's your induced draft. And then, so basically no light, or 8 and 9, a potential board failure. But again, you know, do your due diligence. If it's off, make sure it's powered first before you say, hey, I need a new board. All right. Just a note there, when W1's energizes, the burner will remain on for a minimum of 60 seconds. If more than one error mode exists, they'll be displayed in the sequence. So if it has a 4 and a 7, you're going to see 4 flashes first, then 7, and then it reverts back and forth. Resetting the codes. If it's a soft code, we're really just talking about clearing the 24 volt call. So we're going to recycle 24 volts. You know, I just take the R off. It's up to you guys. You can do whichever one depending on what it is. But flame sensor error is temporary. It's going to keep trying until it gets to a soft lockout. If we get into a bunch of rollout switches, a hard lockout. So again, that's a 24 volt recycling. Excuse me. Control fault is a hard lockout. Try and recycle the power. If it comes right back, you need a board. And then the defects and the number 9 there kind of goes both ways. Sometimes it's a weird thing that happens. You can reset it again. If you reset it and you get it right back, there's a good chance there's an issue in that board. So again, it's always looking for proof of combustion, right? In the older units, we used Hall effect sensors. Some of the newer units, they're just looking at RPMs and different things. Pressure switches, integrated gas controller, 1/4-inch spade, which is pretty common for just about everything in HVAC. So suppressor switch, if the unit has it, depending on what it's there, just a basic diaphragm switch, nothing out of the ordinary there. Normally open to close on negative pressure. Just like the furnaces do, the residential furnaces, same basic way. Just anything more than 3 inches of water column is going to destroy the diaphragm. So just be careful if you're trying to blow in at the test, you might blow the diaphragm. There's your pressure switch wiring. It's a basic open close situation. So if it didn't pull closed, obviously it's going to shut you down. Nothing's going to happen. And the board's looking for that 24 volts at that second PS terminal. Let's say, yep, hey, this closed. We're good to go. Now I can start the rest of the sequence. The Hall effect sensor, been around for a long time, as you can see there. It's a love-hate thing. Some guys are okay with it. Some guys hate it. It's basically just a magnetic switch that's monitoring the RPMs of that motor. It's supposed to prove that it's working. So you can see it here on the back of a motor. It's got a little magnet in there that it turns as the motor windings turn. And as long as it hits its rotation in the right amount of time, everything's happy-dory, right? So once that's verified, just like in a residential furnace, then it goes through the rest of the ignition sequence. They are pretty simple to test. You're really just looking for voltage, right? So between that black and red lead, we're looking for DC voltage. Between pins 3 and 2, which is another black and red lead, you're looking for 21 to 24 volts DC, 2 sides of the switch. Okay, that's the little rotor in there, turns around inside that device, and if it hits it fast enough, everything's fantastic. So we're looking for that first. If you have that, then your issue is most likely in your control board. If you don't, then we're looking somewhere else, right? So if we have that and we're getting the right DC voltages, then we're going to go over, and if the Hall effect is bad, then we're going to check the wiring, and we're going to manually turn that motor, and we're going to look for voltages at different points, basically halfway. You're going to turn it one way, you should see, less than 1 volt. And as you turn it another halfway, you should see that 6 to 9. And then you do the test again on the other one, you see that. If you're not, if it's outside of those readings, then the switch itself is bad. So again, we're talking right here. This is the 1, 2, 3 are showing is where that wires into. That's your Hall effect switch wiring. So here's that first test. We're looking to make sure the IGC board is good. We're testing between 1 and 3. Yep, we got our 7 to 10. Then we're testing between 2 and 3. We got our 21 to 24. All right, so we're inside that range. We're saying, all right, at this point, our IGC is fine. So then again, now we're going to reconnect it, and we're going to test it. We're going to do a half turn. We should either see 6 to 5 volts or basically nothing. And then we're going to do it a half turn, and then we should see the opposite. If you don't, got a bad switch, off we go. All right, rolled through that pretty quick. Any more questions? Excuse me, I'm going to get something to drink here. I think the switch was really just, engineering. Hall effects are a weird way to do that. The pressure switch is a little more solid way to say, yep, I definitely have negative pressure here. Um, it was just a progression, I would imagine. I've asked that a couple times, and sometimes they just look at me like I have three heads. Like, why would I tell you? Um, but I like a pressure switch better than a Hall effect. It's pretty easy. Plus, it's a lot easier to test. If the switch is bad, you can jump it and off you go. All right, metering devices, commercial units. So the biggest one that you run into that throws everybody off is what they call the Accutrol device. It has a bunch of fixed orifices off the liquid header feeding the evap coil. If you think that this device, its metering device is bad, there is a pretty simple way to check it. It is not a serviceable thing, a lot like a TXV. A TXV either works or not. This is the same way. So here's the top picture, shows an Accutrol, so it's blown up obviously, but you can see the indents in the piping. That's where the orifice is fixed in position. If your header has smooth pipe, you don't have that type of metering device. So basically it's just, hot gas comes in, it hits that device, and it's distributed evenly through those. If you have a double coil, obviously you're going to have two Accutrols. Otherwise, you're going to have one. So disconnect the power to the unit, right? Just because that's a safety thing. Disable the indoor fan. Take away that free stat from the evap coil. Again, depending on the unit, sometimes you don't have one. Jump out R and Y. Turn the power back on. Look at your refrigerant pressures. Watch that Accutrol manifold there. Obviously, they should all freeze up fairly evenly. If one or more doesn't, or not at all, then there's a problem there. So we're replacing that. And you can do just the header. We can order just the manifold, or some guys just choose to do that entire evap coil. Total preference. Obviously, Carrier Bryant would prefer to you just to do the manifold, but not a huge deal either way. The warranty won't give you an issue, whichever one you order. So one thing just to remember is when you're replacing that, there are some check valves in that assembly. We just want to make sure that those are there. This one throws guys off a bit. A high flow valve system. It's only used by the factory. Takes a special tool to take it apart. You can replace it. If it leaks, they do tend to leak over time, just like everything else. Part number is there. It's called CoreMax, or a high flow valve. Again, it's only the factory. So if you want to grab one and replace it, great. If you want to try and seal it off somehow, that's great too. Nobody's ever going to say anything to you. All right, questions on any of that? Awesome. All right, now we'll start to dive into some stuff. So we'll talk a little bit about the dehumidification in commercial. We will hit the humidizer option a bit as we go through. So it's just a basic example of, it's a secondary coil that sole purpose is to help in dehumidification. It really depends on your application. If you need it, depends on how much dehum you really want to effect. it's there as an option. So you got your fan deck, your evaporator coil, and then your humidifier coil. Again, most people know the story of Willis Carrier. You know, back in the early 1900s, he's the one that came up with the idea about saturating air and controlling the temperature at that saturation to be able to pull moisture out. So basically, his main invention that he came up with was how to dehumidify air in a controlled space. And then, of course, this chart that everybody's seen 1,000 times is his design as well. Pittsburgh, PA guy. So, you know, what's the purpose of it, right? So obviously comfort is the most important thing. Anybody who lives in an area that gets some serious humidity knows the difference between whether it's humid or not humid. No matter what the temperature is, you know the difference. So again, human comfort was the biggest thing. IAQ issues, right? Indoor air quality issues. Too much humidity, we start to talk mold and mildew and bacteria and all of that fun stuff. You know, and without a way to remove that moisture, it's going to happen. Whether it's a modern house or something from the 1800s, it's going to happen. And then, of course, you know, that's damage, right? Office equipment's damaged, manufacturing equipment, supplies, all of that stuff. So we all know the benefits of dehumidifying a controlled space. Ventilation's requirements, you know, if we had a lot of humidity, maybe you're on the coast or in an area like I grew up in Baltimore, I think it's where they invented humidity. You needed it there because there sometimes it was so thick you couldn't breathe because you're right on the water. Could be an issue with ventilation of the space too. So now we're taking care of some of that because we have poor ventilation in those areas. And then, you know, it affects equipment depending on what type, you know, maybe glass is freezing up or grills aren't working or, you know, jamming of paper or you know, in paper mills or printing shops and stuff, you know, we all know that what humidity and moisture can do in a space. So again, here's just a little chart about what percentage of humidity we get to when things start to grow and get bad. We all know that 60 is really supposed to be that end spot, right? If we're above 60% humidity, we got some issues. And as we know, when we get low in humidity, we have issues as well. You know, that's where the human factor comes in again. You know, now we're really dry and we got those dry nasal passages, or if you got allergies or static electricity, right? We've all probably grabbed a doorknob and got a jolt from time to time. So that's why in the wintertime we're humidifying, and then in the summer we're trying to dehumidify, right? If you really want to know, you know, if you're bored one day, you know, there's a great ASHRAE standard out there. Talks about ventilation rates, indoor air quality, what's acceptable, what's not. If you're in one of those situations where you're designing what it needs to be, that's a great resource for you. It's out there. And then again, what's the main point of all this is that we're trying to maximize human comfort, right? And then human health. So just typical building things here. Schools, high percentage of outdoor air per student, you know, they're in and out. We got people going on. Restaurants, high humidity, kitchen, dishwashing, cooking, outdoor air, all kind of stuff there. Supermarkets, again, a lot of people in and out, doors opening all the time. So we got issues. Health clubs, obviously, right? You know, everybody's in there sweating and carrying on, you know, if you do it right. Humidity issues there as well. So they definitely need some way to dehumidify other than just an air conditioner. So biggest thing is a lot of guys try and chase the humidity in the building. They kind of go too much. Maybe they're overcooling, uncomfortable temperatures, you know, in space. You know, try and change the operation of the unit, adjusting space temperature, humidity, all that stuff. You know, the biggest thing is you just need a way to dehumidify that's not just an air conditioner. There are just spaces to where just an air conditioner isn't going to work. The up and down is too much. So how do we do this, right? So the base model rooftop without any additional things, we know air conditioning can dehumidify, but when the compressor's running, it pulls a lot out. And then as that compressor stops, now we get into this ebb and flow of now we're bringing it back in, or somebody opened the door or whatever. So, there's always this ebb and flow going on. We'll allow a few minutes. If we have a dehumidifier, we'll allow a few minutes for that cool to warm up. So then we're going to be able to do it more effectively and work through that. So just a basic package, rooftop, constant value thermostat, it's just on and off, right? So unit cycles on, we haven't reached saturation yet. So at this point, no dehumidifying yet. We're blowing some cold air, but that's all we're doing. And once we get to that saturation temperature in your refrigerant, so now we're starting to dehumidify a little bit. And of course, once we hit the set point, that everything cycles off, and any moisture or anything in that coil at that point, now we're blowing air through it and we're throwing humidity right back into the space. Maybe not as much because we pulled some out thanks to our condensate line. We see it dripping, but we're still doing that again. And then of course, as that stays off, we get right back to the same cycle again. So we're going to redo it again. So what do we do? This is part of that document I showed you. 75% of the energy for reheating or providing warm air in mixed systems is provided from a site recovered condenser heat or solar heat source. So true dehumidification is coming from something else. Hot gas reheat is what we're going to talk about here in a little bit. And this is a way to increase and make dehumidifying more efficient. So no matter which manufacturer you're looking at, everybody uses this method, this series flow or parallel flow, as we'll talk about, to provide dehumidification. Refrigerant flow, it comes from the compressor, hits a three-way valve, controls, goes to a reheat coil. In dehum mode, the three-way valve diverts the hot gas into the reheat coil within the indoor airstream. Reheats the indoor air to a neutral temperature. You can sometimes overheat it in this configuration. So again, we're fighting against our cooling a little bit. The refrigerant is then subcooled in the outdoor coils and flows through the evaporator. In cooling mode, the refrigerant flow path is not altered from the standard flow path. Indoor air supply air flows in the evaporator coil where the air temperature drops below the dew point and moisture is removed from the air. The air then flows over the reheat coil and is heated to a neutral temperature. So, it goes through quite the rigmarole in this series flow. So a parallel flow, very similar operation. Compressor again, three heat valve, controls condenser bypass line, dehum mode, where a three-way valve sends it through the hot gas refrigerant to the reheat coil. Indoor air is reheated to neutral temperature, just like before, just kind of a different path here. The outdoor condenser is completely removed from the flow path. The reheat coil serves as the only condensing coil. So a little change there with parallel than from series. And then this supply air, basically the same process, heated to neutral temperature, allowed to do that. So you got series flow, parallel flow, and now a two-phase flow. So still very similar operation here. From the compressor, the hot gas refrigerant flows towards a condenser. dehum mode, condenser bypass valve controls the amount of hot gas bypass. So now we're starting to control it a little bit instead of just opening a valve and letting it do its thing. The amount of bypass determines the reheat capacity of the system. If more hot gas is bypassed, the reheat cool downstream will receive warmer refrigerant and heat the indoor air. So, we're starting to change that a little bit. A lot of pros, no cons really here. Three-way valve introduces, removes the coil. So now we're starting to meter that a little bit, trying to keep that overheat from happening or getting past the neutral temperature. The advantage to this system design is the multiple options available controlling the refrigerant flow. So now we're in two-phase. Now we're controlling that flow a little bit to maximize what we're trying to do here without any cons, without any reheating of air or overdoing whatever. The humidizer option is out there, and it combines the old moisturizer methods and two-phase hot gas reheat system. So now we have kind of a combination thing going on. The humidizer coil is the reheat coil, reheats the indoor air to a neutral temperature after the moisture has been removed, right? The condenser also has an added hot gas bypass line to bypass hot gas around the compressor. So now humidizer is, a combination of what we've learned, what we see, what works better, and now we're doing it. We got some refrigerant flow now, we got some metering now, and we're going to roll on. So normal mode, call for cooling, used when a high degree cooling is required. Design cooling days, low ambient stuff. When a humidizer, I could have thought of a different word. It's combined with a 2-circuit unit. Again, the 03 to 28 is the size. It's not RTU. Depending on the space conditions, one circuit could be in hot gas reheat mode, while the other one is in subcooling mode, often refers to as the fourth mode of operation. So this gives you a lot more options than just a basic series flow or two-stage system. So we're changing things up, we're metering it, and then as they're slowly going through, they're trying to improve. So refrigerant and hot gas flows from the compressor into condenser, just like always. Where it is condensed to warm liquid flows into the TXV and becomes cold liquid. Cold liquid flows into the evaporator where the indoor air is cooled and evaporates the refrigerant to cool gas. The cool gas flows to the compressor. So warm liquid flows from the condenser through the humidizer or the reheat coil, reheats the indoor air to a cool 60 to 75 Fahrenheit. This subcools the refrigerant to a cooler liquid. Cooler liquid flows through the TXV and changes to a cold liquid. Cold liquid flows into the evaporator where the indoor air is cooled to a lower than normal temperature and evaporates the refrigerant to cool gas. Indoor airflow really doesn't change. Again, that's where we're removing things. So it flows through a subcooled evaporator at this point, where the air is cooled lower than normal temperatures and the moisture is removed. So instead of heating it like the older systems do, now we're doing it in a cooling mode, and they found that it's more effective. If we get that call in these systems to where they just want dehum, and you always have a separate humidistat wired into this somewhere or another. Now there are some more expensive controls out there where you can do it together, but same basic system, obviously just without the compressor at this point. So we're just running the system. We might just run it in single stage at this point. A lot of the newer units they're controlling the outdoor fan. They're lowering that down to kind of get that up and work through that operation. Controls are two options. You can have a space or duct mounted temp sensor, duct mounted or a space humidity sensor, totally up to you. Mechanical controls, that old Edge Pro, that's the 33CS is still out there. The older one's not too much. For temperature and humidity, some guys use a basic thermostat and just add a humidistat. That's fine too. Whichever works. The wiring is the same. 2 wires go to the board for the humidistat operation, and then the control goes just like it always was. So just real simple, depending on what inputs we're getting is what it tells the system to do. If we have an economizer, which you can with a humidifier, they'll work in conjunction. So depending on what call we get or what mode it's in, it'll, as you see, it'll send, are we in subcooling mode? Is the hot gas reheat on? Yes, no. So it just depends on where the inputs are and what the system needs to do. So it'll work easily with an economizer. So, you know, the units will stay on longer since we're supplying warm air to the room. You know, stay on longer and provide continued dehumidification of the air. So if we're just running in dehum mode, we're going to be able to dehumidify. Off-peak operation, you know, you can have that set up there depending on what you want. So there's an option there too. And, you know, again, partners is your friend. If you don't have access to that, you really should contact the branch and make sure you are, because there's so much in there. It can be a little wompy as to how you can find it and what you can find it, but as you get comfortable with it, it gets easier. As I said, this is just some screenshots off of things that are in partners application data. There's white papers out there telling you different things, competitive comparisons. You know, again, it'll go through that series flow, 2-stage, and all that fun stuff. All right, I've been yapping for about an hour. Anybody need to get up, take a break? What do we need? Send me a message. All right, I'll keep rolling. So we talked about that reheat board. Again, that's just a secondary board that's going to control dehumidification. There's a relay in it. So again, once the signal comes in for dehum, it's going to operate reheat board. That's where you're going to turn on, you know, if our RSVs or whatever we've got tied in, depending on the unit. We get the signal from Y1, we get a T-stat G call, we get an indoor fan operation, CTB powers us, so we get R from the control board, and then humidifier operation on that jumper. So again, if we just want dehum, so the reheat board is going to be powered, compressors off, all valves in normal state position. So we're just kind of sitting there, just showing you the normally O's, normally closed options between those signals there. So we get a signal for fan, cooling call only, and first stage cooling came in the reheat board, signal sent out to run fan and compressor. Valves are left at normal state position. Outdoor condenser coil is used, humidifier coil bypassed. Dehum call, you get fan, dehum, come in the reheat board. So then we're going to send a signal out to run the fan and compressors. Both of the valves are energized at this point. Outdoor condenser coil is bypassed, humidifier coil used for condensing in our humidizer. So again, some of the other ways we were using the condenser coil, here we're not. So you can have both. You get a signal for cooling and dehum. Signal sent out, runs fan and compressor. LSV is energized. Outer condenser coil is used at this point because we have a cooling call. Humidizer coil is used for subcooling refrigerant, so they work together. And you can effectively do both now. And it happens. And again, at this point, unless there's some weird thing, which our standard guys, if any of the standard guys are here, we know we had a little issue with a low ambient control that was keeping the fans from ramping up, and we weren't dehumidifying right, and we were blowing a compressor. So there's some hitches with everything, but when everything is right, this thing will run at the same time, and you'll get great operation for your customer. Humidizer questions. Well, you guys got to still be awake. Not that boring. All right. So tomorrow, Monday, when you call me and ask me a question, I'm going to ask you why I didn't pay attention, right? All right. So we'll keep rolling. Yeah. Rick needs a $5. Anybody got a problem with that? All right, we'll pause. How about we'll come back at 5:30? Or I'm sorry, 4:30. All right. I'll talk slow here and get started. We're about halfway. Try and talk faster. We'll see how this goes. All right, so rooftops at times, depending on the application, need some low ambient controls. Especially, again, if we want to operate air conditioning below the standard operation ratings of 60 to 70 degrees, right? Depends on the rooftop model. It gives them year-round cooling if they want it. Economizer is optional. Just depends on what's going on through that. You have MotorMaster 5, which is probably the most prominent one that's out there that helps with low ambient controls. There's a MotorMaster 1. We got a MotorMaster 2, which is a little different operation, just a basic low ambient pressure switch. So again, depending on what you got going on, what you really want to do, I'll try and breeze through these pretty quickly. But again, if you got questions, I'll keep checking the chat line. So and then the winter start kit, which is your time delay. So, MotorMaster 1 allows operation down to -20 Fahrenheit. Some of the numbers have changed. The control hasn't, sometimes part numbers change. So you can get that single phase, 208 volt, 460 volt. It just depends on what you're going on. This one does it depending on what type of motor you have, condenser fan motor. We may need to make sure it has a ball bearing motor. And then again, we may need to change the run capacitor. So if you're not sure, that's a great question. Give us a call, give us your model number. Let's see what you're trying to do. We'll help you out. Sensor location. All of these are very specific as to where they want their sensor. This one happens to want it at the top of a manifold there. So again, the instructions are going to have this picture in it. Our pictures and instructions always great. No, again, when in doubt, send us a note. This is what we're trying to help you with. This is stuff we're here for. So depending on the unit you have, we're going to get that sensor in the right place. Obviously, if in the wrong place, we're not going to operate right. So winter start control required again. That's just that delay. It's also what bypasses your low pressure switch, because obviously in colder ambient temps, we're not going to have the right pressures for operation. R22 smaller roof box, we're going to replace the low pressure switch. 410A, for the most part, you're just going to run this parallel. It's not the best picture, I'm sorry. But again, we're just going to hook this up, and we're going to start to control that outdoor fan. So we're going to run power into the control and then back out to the fan, so that if it engages, it shuts the outdoor fan down. And then of course, we get our temperatures up a little better and we get some cooling. At times, again, depending on the models you have, in this case, a 3-phase, 7.5 to 10 ton, there's a bypass relay that's needed. So obviously we're going to wire that in, and sometimes you really have to look at what unit you have, what model is it, what's the tonnage, to really know everything that you're going to need. The relay is for heat pumps, obviously. If it's not a heat pump and it's a gas electric cooling, we don't need it. So again, wind baffles for this low ambient control is needed, because we want to get that cold air off of that coil a little bit, so we can get those temperatures and pressures up and get some effective cooling going. Is it great cooling? No, but it's enough. So Motor Master 2, again, that's another option depending on which unit we have. Does come in a control box at this point, instead of just some controls in a box, right? So you got a nice control board there, coil sensor, the wires to your motor, contactor, and some mounting hardware to screw it on there. Pay attention to which door you screw it on. I've seen plenty of pictures to where it was put on a filter door between it or something, and now you can't get the filter off. So again, silly stuff, but watch where you're mounting that. Cooling down to -20 again. Does need some extra accessories. You control up to 2 motors with this one, so you can do both fan motors if you have it, or if you have multiple ones, at least you're shutting 2 down. Maintains the leaving coil temperature. That's where the sensor is located. Again, critical location. Single phase motors only. Fan on and off operation based on that sensor temperature. So again, that location is critical. Multi-tap transformer. Unit fan contactor starts everything, powers up transformer, powers up circuit board. Field supply, again, relay for heat pumps, just like the one. 10K ohm resistor. So again, if you got that 10K chart, if you're testing that resistor, you can use that chart, you know what's going on. T1 is just the W1 connection. So 70 to 50 degrees, W1 to T2, 130 to 110 degrees. So that's what you're looking for when we want this operation. Again, you can see sensor location is a little different here. We're down just below halfway point where they want this one. And then again, depending on the tonnage of the unit, that may change. So we really have to pay attention to where that is. Again, if you're confused, that's a great phone call to make, or email or text or something. Thermistor resistance, the colder it is, the higher the resistance is. So they're an NTC resistor, just like a lot of the residential units out there. So again, you're looking at that chart. If it's 40 degrees when you're testing it, you should see what's that, 28 to 30,000 ohms. Wiring, again, since this has a control box and there's some fixed places, wiring again here. So we got the unit control box, which is sending power down to the outdoor fan contactor, right where that comes in. So we're powering that. We're breaking the motor leads. which again, sometimes we got to watch what capacitor we have and we have to change that. And then that's how, depending off of the thermistors, whether it runs a fan or it turns it off or how it's going to operate. So again, you're just breaking that line so that if the motor master doesn't need to operate, the fans run normal. If it sees a point that, hey, we're getting too cold, it shuts down the fan and everything else keeps running. And that's, the basic thing of any low ambient control. The old faithful, right? Just the basic low ambient switch, 2-wire switch, hooks right on your service valve. It comes with a T to make that happen, so you can still hook up your gauges and check pressures. This one only cools down to 0. Does require some additional accessories, winter start kit usually. A couple other things. It can only control one fan motor, it just has 2 wires. Basically turns it on or off, depending on the pressure, shuts down, just opens up. If it opens, it shuts the fan off. Once it closes, it brings it back on. Wires in series. If it's a 410A version, over the 200, closes at 365. So it closes, brings the fans back on. We start to drop temp down. Or 22 the same way, just opens at 100, closes at 225. Wiring, again, you're just breaking that connection to the fan motor. We're taking that line voltage, instead of it going right to the contactor, one's going through the switch, the other's coming out, going to the fan. So talked about that winter start kit. So this is just a relay, time delay relay. Does come with instructions, take them or leave them. They're there. Cooling down to 25 degrees. More accessories may be needed. Again, it just depends on what you're using it with. Bypass is the low pressure switch, and it's wired in parallel. Once we get to that, you'll see that I'll show you what one of the big mistakes people make, because then we come back in normal cooling season, and now this thing's not working because of what they've done. The wires are in the kit, so it helps out. So here, we'll skip that and go to here. Again, you can see down at the bottom, we're not disconnecting the low pressure switch. We're leaving that hooked up, and that's the biggest mistake that we get phone calls for. Guys are cutting those wires or taking them off. It happens, right? So we're literally just adding this winter start control to that circuit. So one wire comes in on the intake side, and one wire comes off on the outlet side. And then if the switch does operate, but we're in low ambient mode, then everything's going to keep going. I have heard a few guys, maybe there's a delay between the two and it shut off and kicked right back on. But for the most part, you never know what happened. So just make sure we're not cutting the low pressure switch. We're just adding this on those terminals. And then just 1 to 2. And then of course it sends out a common and a signal to the motor to tell it to keep rolling, to the system, forgive me. So again, when you're looking at one of these, full model number, huge accessories, some need wind baffles, depends on the unit, depends on the application. If you got a good false wall or something, maybe you don't need to worry about it. Temp switches, free stats, ball bearing motors, at times you're going to need it. Sometimes capacitor changes. Those are those little things that, oh, I just need to make this run, but it's not going to operate. So probably the most popular one, I think that this one is the one most people like to use. It has a transducer in it. Again, an access T again, some wiring. It does come with instructions, not just a knee pad, right? They're there for a purpose. Motor controller, fan relay, got some wiring harnesses, some fuses. Controls down to -20, so now we're back to -20. Wind baffles are required And if you're using this one, it doesn't matter what your application is at this point. Put some wind baffles on it. 5 mile per hour winds and or 30-degree outdoor ambient temperature. So again, it's going to look at both, and it's going to help you if we got some wind and we're cooling things off. Now we're going to do both. That controller is basically a small VFD for the fan motor. Has to be a ball bearing motor. And then if it's a heat pump, we need that additional relay. When we're wiring this up, that transducer is polarity sensitive. So if you're getting some weird stuff, that's the first thing. Switch that up. Maybe you cross wired it. 3-phase motor controller. It is factory programmed. The accessory kit is matched per the unit model and size. So again, it's great to have that information. Does have to be grounded just because it's the VFD. So we got a control there, we got a ground, make sure that's grounded. Powered up at all times. Fan relay starts the signal. So again, there's your fan relay contacts. You can see you just wired it in there. Orange off of number 1, number 2, which to your fan relay. Everything else here is here's your line voltage in. There's your motor master control. So we're putting the power into the motor master and then letting it out to our fan motor, just like the indoor VFDs, right? Everybody's favorite. So again, there's the outdoor fan contactor. We got your fan relay wiring. Here's a transducer that wires into that MMV. You shouldn't be able to cross that up, but it happens. So just make sure that you got red, green, black, or if they change colors at some point, make sure they're in the right spot there. T1, T2, T3. You know, instruction packet, right? I know the old joke about instructions. You know, take a second if you've never done it. There's a wealth of knowledge in there, and it'll save you time and energy and frustration. You know, if we're busy, it's frustrating to get a hold of us sometimes. Down to 20 degrees again, does everything further accessories, right? So we're talking wind baffles or whatever. You can do 2 motors with this one. So depending on the size of the unit, you can shut 2 down if you want to. That's weird. That got pushed over to the side. I'm sorry. Maintains leaving coil temperature. Sensor location again is critical, just like all the others. Single phase motors, accessory relay for heat pumps. Same as all before. Solid state control board in there. There's a potentiometer in there. Controls voltage output. Output voltage change, full or 0. Lower RPMs, higher amps. 5 K ohm temperature thermistor. So that throws people off sometimes because they're so used to the 10K with the other ones. So same operation, different chart to check it. All right, so just we talked about this, just the basic wiring there. So you can see your low pressure switch, your outdoor fan contactor, your unit control box. And now we're using the speed control and the temp sensor to send power to the motors. And then your low ambient relay to one of your other motors just to monitor what's going on. So that's a 460 3-fan unit. So again, seen this plenty of times, right? This is the 5K chart. So if you remember, if anybody's been in the residential trainings, when we talk about the outdoor units, we're always talking about that 77 degrees, right? That's the sweet spot for sensors. Same thing here. If it's a 5K 77, we should have 5,000 ohms, right? If it's a 10K at 77, we should have 10,000 ohms. So same basic operation, just depends on what the sensor is rated for. Again, location is critical on these. This location is very similar to the MotorMaster 2 to where it wants to be, to where it's just about halfway down on that location. Not always the easiest thing to do, especially depending on the unit and getting your hand in there. But if you're off, the whole operation is going to be off. So you're going to have to make sure that's in the right spot. So again, just the part numbers here, depending on your voltage. Obviously, you got to have the right one. It's happened many times. You can see how similar the 208 and the 461 is. You've got an 031 or an 030 or an 032. Somebody's keying that in, man. It's, it happens. But that's one of the things that one of the first questions we're going to ask you are, hey, what part number did you get? What's your voltage? So hopefully we can help with that and make it painless. So packages in there, you got some fuses, fuse block, relay base. You're going to get the covers, transducer, so it's a complete kit when you're buying that. And then again, winter start kit for each circuit. So if you got a 2-stage system, you're going to need a winter start kit for both. And again, that's that relay that's just bypassing that low pressure switch so you can continue operation. And then wind baffles. All right, breeze through that really quickly. Questions? Awesome. All right, economizers are awesome. All right, everybody loves economizers. Piece of cake. Hook them up, plug them in, off we go. I haven't seen the Bryant man in a while. They used to have a guy that went around in that suit to certain trade shows and stuff, but I guess he's retired. All right, so how economizers work, right? It's one of those calls we get. It's that monkey in the middle. It's like heat pumps for some reason. You get all worked up about it because now you got an O call and a reversing valve and a condensing unit, and you're like, oh, what just happened? Not that complicated once you get a little time with it. Outside air dampers, right? Return air dampers, outside air sensor, mixed air, supply air sensor, economizer control model. So you're going to see those couple of things in here. We're bringing in that outside air. We're only dealing in the return at this point. We're mixing that up, and it's all subjected to what you need, what your setup is supposed to be, how you set this thing up. So basic sequence, right? Thermostat calls for Y1. If it's cold enough for free cooling, we operate in free cooling. We're pulling in that cold ambient air. And then we don't need a compressor at that point because the air outside is cold enough. We're cooling off the space. Appropriate changeover command, whether you have a dry bulb or an enthalpy curve or a differential enthalpy. Again, that's up to what we're trying to do and how we have the unit set up for. Dampers will modulate to provide 50 to 55 degree supply air or mixed air temperature to the zone. As supply air temperature or mixed air temperature fluctuates, the dampers will modulate to maintain a set point. Again, above 50 degrees, those thermistors, the dampers will modulate from 100% to minimum. Between 45 and 50 degrees, the dampers will maintain a minimum position. Below 45, the dampers will remain closed. All right. Important thing there. Test question. Below 45 degrees, SAT, MAT, the dampers will remain fully closed. Free cooling is not available. Then, of course, compressors are controlled by Y1, Y2, and the thermostat. Again, in this, you got a mixed air or supply air sensor located there. You got your outdoor sensor located. Dampers are 100% open, so we're pulling in all that fresh air. We're doing that out. We're throwing the indoor air out, pulling in fresh air, operating through free cooling. So it's cold enough outside that we're just pulling the air from the unit out or the building out, expelling that out, and pulling in fresh air from the outside, going through the evap coil, getting down through the blower, cooling the space off. Compressors are off. So now the outside ambient temperature is above the OAT set point, right? So now dampers are at their minimum position. So we're still bringing in a little bit of outside air, but not much. We're still using the indoor air and the outdoor air, return air, throwing it through a coil with a compressor operating, just like normal cooling. They always talk about making sure you're using a relief damper, especially if you don't want to over pressurize the building, because then doors are slamming and carrying on. Doors open, moisture issues, drafty noise, those type of things. If you've been on a roof, I think you know this control's been around for about 20,000 years, I think. Actuators really haven't changed all that much. They still pretty much look the same. It's not an overly complicated control. Can be a little confusing, again, if you've never done it, but so again, here's you'll see this economizer 4. That's definitely a Carrier Bryant name for it. You know, it's got its own part number, but it's a very popular one that's out there. You see economizer 4. You also see economizer X. So important information for later. So the motors do have an over torque sensor. When closing, it will sense if something's tight and it'll stop. So maybe some debris got in there or something, who knows. Yeah. So that's there to protect your actuator motor. Standard 2 to 10 volts. So again, when we're testing, we're looking for DC voltage. This one is a spring return, closes on power. There's no linkage or anything really overly complicated in there. Everything reports here. So we got sensors out there, whatever wiring, it all comes here. So whatever that system wants, when the signals come through, it's coming here. Low voltage side and controls on the right, settings and supply thermistors on the left. That's a blast from the past. I was going to change it, but I haven't seen that in so long I left it there. Standard outdoor sensor. Of course, now we're using the newer version of it, but outdoor ambient air 40 to 100 milliamp signal. So when we're testing for signal, you got to have the capability of testing milliamps. Max supply voltage 23 DC. So again, the dip switches on this, just like a lot of the newer ones, what temperature do you want it to monitor? And then that's what your dip switches determine. All right, so easy test question, what does OAT stand for, right? We see it all over the place. Outdoor ambient thermistor, right? So depending on where that's located, here we've located that one there, right on the outside of the unit. It's the best place for it. Depending on what you got going on, sometimes you can put it in a different spot, but that's usually where they're located. That one throws folks off a bit, the ABCD selection. Again, it's just a matter of temperature, right? When do you want free cooling to activate? So obviously D is the setting that we use most in our area, which gives you that 45 to 55. So if the temperature is below that, that's when free cooling is going to operate. And then again, if you're not getting that, then we have to go back to our thermistor, because that's where it's getting its input from. Maybe your thermistor's off, or maybe it fell down, or whatever, got some debris on it or something, who knows? But that's a big part of it. That's what those for. A is the highest. Obviously, we have no need to keep it at A. I know some folks that use C, but for the most part, it's D. And then there is a version of this that has an E, but I mean, that's 30 to 40 degrees. That's too low. So mixed air sensor, if you have this style sensor, then that's going between your T1 and T. It's a 3K ohm resistor. So again, you're going to have to find yourself a 3K chart. There will be one in the instructions if you kept the hold of that. So there's the chart for that. Again, you see at 77, that's for whatever reason, that's a sweet point for a thermistor, 3,000 ohms. And if you really are happy, there's a Celsius version there for it. You know, we always want to try and troubleshoot a sensor at least 2 different ways. So you want to look at the chart and do your ambient sensor. But then the best thing is if you can, again, we've talked about it before, find that ice water, get some ice water, stick this thing in ice water and verify it a second time. Don't just go off your first reading because, again, you know, we're talking about resistance to temperature and a change, and it might be off. But if it's off twice, there's a problem. Just happened here. I lost something. Okay, again, just testing wise, sorry, that was weird. If the economizer still won't open or you have some issues, you know, check your connections, right? There's obviously one that from a distance, it probably looks like it's connected, but it's not, you know, the female and the male are definitely not together. So silly things, but hey, make sure it's in there. So again, I talked about how the right side is your first stage cooling input, first stage mechanical cooling output. So again, we're in and out, just like we talked about in the board. Now the signal's coming in, we're going back out of the economizer, going to the board. And there's just, you know, just another version of that. So here's your low temperature pressure lockout because the low temperature switch is either closed or open. And says, hey, we're not going to do it that way. We're just going to pull in some outside air. If the outdoor airstream, which is used to block out the compressor, is below 42 degrees, special accessories are needed for equipment operation below that. So again, now we're talking low ambient kits and whatnot. So the factory default for this when you get them, especially in the Economizer 4, is occupied mode. Occupied status is proved by the black jumper that you'll see on the unit. Between TR and terminal N, when you need to do an occupied, unoccupied, install field supply time clock function or however you're going to do that, place a jumper there and do it that way. So, but for the most part, most people do not do that. So that jumper is really just there. Again, N is powered when occupied, not powered when unoccupied. So again, if we're doing that, here's your connection. N1 and N is considered occupied. Why they used N instead of O, C or something, I don't know, but it's been that way a long time. And the TR factory installed jumper, N1 is the common side of N. So depending on what you're trying to do, there's ways to do that, and your economizer will respond for you. Minimum ventilation, usually specified by code, or if you have an engineer or something, somebody somewhere should know. Percentage of air, it's not marked on this control. Even if it was, it doesn't really tell you the actual air intake. Again, you're going to have to work through that. So thermostat calling for fan only. There's no cooling call. So, you know, we're setting minimum position at this point. If you can do it by hand. Damper movement from full to open, closed should take about 2.5 minutes. So if you're looking for something instant, it's not going to happen. Change your minimum position. Open is fully clockwise, fully closed, you know, is counterclockwise. So there is a formula that you can use if you really want to dial in this. Most people just leave it at the defaults which we'll talk about, but this will be in your packet too when I send it out. If you want to use it, you got at least a 10-degree difference between outside and inside air. So basically you got to have a load. You can't go on a 70-degree day when it's 70 in the house. It's not going to work. Or the building. TD under 10 degrees can skew calculations. So again, we just need a load and a call. For best reports, best results set up should be done on the coldest part of the day. So again, we're trying to set up for free cooling, right? So try and do it when there's the biggest load. So P1 and P, remote potentiometer is located in the occupied space. It can be added if you want. This is an addition, not a need. But if somebody wants to be down there messing with it, you can obviously put in a remote one and let them do that. That's what these terminals are for. So again, if we're testing this, power is the biggest thing. So TR stands for transformer. 24 volts, right? Because we're powering 24 volts with everything at this point. So if you don't have 24 volts at TR and T1, you got to go back and figure out what's going on, because your economizer control is not powered. And depending on which economizer you have, some of them may be fully open, some may be closed. It doesn't matter. So now, and of course, if you do, then as you turn this potentiometer, you should eventually see activation. Demand control ventilation, or DCV as the abbreviation, is there if we need to, use an air quality sensor, CO2 to modulate. So, that's when we're getting into that, to where if we're trying to monitor for CO2 or whatever the engineer or the building needs, that's what these are set up for. Standard economizer setup, you're not going to have a CO2 sensor. So DCV is set fully clockwise. The max is counterclockwise, so it's going to be open all the way. We're going to get full max, so you're going to get 10 volts. No power exhaust. So that's the basic operation. It's very rare that you ever use the EXH or DCV control. So just make sure they're open. If you're installing a field one, that silly little part there is your friend. Put it in your tool bag. Don't let anybody know you have it. Keep it for yourself, because as soon as somebody knows you have it, you're going to lend it out, and then you'll never see it again. You can jump it out without it, but if you have the opportunity to get one, and you can order it, it has its own little part number. It's a huge thing to bypass this. So if we're testing and if we want to get cooling running, then having that plug makes life easy. Otherwise, you use your wiring diagram just like we showed you before, and it'll tell you which wires to tie together, and then you can use an alligator clip or something, or a piece of wire to jump it. But if you have the opportunity to get one of those, I would definitely do it. All right. So the 7212 is on the left here. That's the old version. The 7220 is the newest version from Honeywell. It's a communicating system, so it uses an actuator that it actually communicates with. It's not just sending a signal to. You get them on ultra low leak damper designs. Definitely have to have a standard air volume 2-speed electric motor, electric communicated motor. Again, that's a 7220 control on the Economizer X. So trade name, a couple trade names here, just test questions, hint, hint. Installed, factory installed only, initially factory installed only. Now you can get a field installed. Low leak damper, gears are relocated to the rear side of the damper housing. It has a notch blade that ends are now square cut and seal on the flexible seal. So that's kind of where trying to keep the leakage happening a little more there. So we'll just change the design of that a little bit. So here's your communicating actuator. Again, the operation is still the same. We're talking to the control now between the actuator and the control instead of just sending voltage and hoping it does whatever it does. So 4 keys for menu access, as you can see in the middle. You got up, down, return, access, 2 setup menus, crazy amount of parameters. So you can do a whole lot with this. Set points, 16 parameters. Status menu, there's 26 there. There's a checkout menu. There's an alarms display. So again, it's a huge upgrade from what the 7212 was. The thing is, in this case, everything's color coded. Now, one thing to remember, if you're field installing this and you pull this thing out, there are little green adapter pins that come in the box. Make sure you get them, because if you don't, you're out of luck. Because if you're hooking up wires, unless you have Molex or something going on here, you need those adapter pins. So again, if we have a basic SAT or MAT control, there's a spot clearly labeled where that goes. Your outdoor ambience clearly labeled where that goes. If you're using the newer style Enthalpy, you can't put that on MAT or OAT. That has to go on the S bus terminal. Different communication way, different sensor. So there's been a lot of times where we put it on where the OAT used to be. It will not work. It has to be on S bus. And then, of course, your actuator down the bottom has its own spot to go to. Basic wiring, won't go through this too much. Your blue and gray side, again, now we're on our, just like in the other control, this is on our 24-volt side. This is our inputs and outputs going through here. Occupied if you need it. Ground, definitely need the ground. EXH1, auxiliary 1. Here's your alarm control. Obviously, you can see the gray ones have your thermostat on it. Your inputs and outputs for that same operation. That's terrible. Let's get past that. Mounts inside right at your terminal board. So all you're doing is taking off your electric panel and everything's right there. So the MS31 series actuator is directly coupled, spring return, 24-volt power. So a little different than the other one, right? That was DC. S-bus communication. There's 2 sizes available. Enthalpy differential dry bulb is different termination points. So again, it's customizable to what you need. Nothing really seems to. Some sensors can come shipped in one location and must be moved to the correct location. So again, if it's field or factory installed, you may have to move the sensors. They just may mount it somewhere. So common sense, but just make sure that's there. There's that different enthalpy sensor. Again, you got to tell it what you want it to be. Do you want it to be dry air, discharge air? Do you want it to be return air, outside air? The same control. You can have 3 of the same and they can all be something different. So they're all there waiting for you. The factory setting comes off, so it's factory set for outdoor air. Part numbers again, obviously they change and rotate, but again, the parts counter is great for that. And if they don't know, somebody usually calls us and we'll work it out. So MAT location, it's always going to be in that indoor fan. Even if it's the newer style and maybe you have a vane axial fan, you're still going to locate it in that blower cabinet. The old style used to mount right on the housing, but the vane axial doesn't allow that, so we still just put it in the same locations there. Mixed air supply air thermistor, obviously, that's what we're talking about, putting that there. So you can go into the control and, view the set points to see what you got going on. This is where your adjustments come in. So you get into MAT sets, and you can adjust this if you need to. So again, if it's not quite working right, or maybe it doesn't seem like it's completely accurate, you could, but there's a question about, can you use two of those with only one S bus? You can, but there's really not any situations where you would ever do that, because you're going to have an OAT, and then your mixed air, we can tie in together, or we can use it a different way. So there's a way to do it, but it's not very common. So menus that you'll get into, you got status, which just tells you, is it on? What are we doing? What's going on? Set points, all kind of set points that you can change. System setup, if you have to. Advanced setup is there. There's a checkout mode, so you can start to make things move. And then alarms, if you want some sort of alarm to happen, or you're hooking that up, maybe you need flashing light bulb or something somewhere. So the set points menu contains 16 parameters. So the factory default values, for 15 of these are fairly straightforward. The parameter for DCV, or that demand control ventilation set, should be modified from the default value to enable that if you need it. Again, that's information that you probably want before. The value for this parameter should be higher than the outdoor ambient CO2 level. So again, if you're measuring outdoor CO2 and for some reason you have 500 parts per million, then you're going to want to raise it up above that. Then that's how you set that up. Again, you're going to have to be able to measure that to know if you're setting that up. The setup menu has 8 configuration parameters and factory default control points. The 3 are critical to stage air volume and 2-speed fan applications. So again, depending on what you're doing, I'm going to scroll down, and you're going to double check that. You're going to make sure that the equipment is in what they call CONV. Your aux2.1 has a W, and your fan type has 2-speed. And again, this is right in your setup, and your instructions are going to have it. So again, knowing what you need this to do or what you're trying to operate, sometimes you have to go in and set it up. Factory installed ones, it's already ready to go. This is really for field stuff. If they were given the parameters, if something changed, then of course you have to go in there and take care of it. Indoor fan speed, again, we're talking about staged air volume. The 7220 does not determine fan speed. It just knows there will be a fan speed. So again, depending on what the inputs are, then the system kicks back in and decides what the fan speed is going to be. Again, just a little different setup here. The order of capacity stages is based on increasing cooling demand from the thermostat, right? So again, we know the thermostat's the lead in all this. The economoster is just kind of following along. I'm going to skip that. We've talked about that enough. If we're doing that, then again, CO2 sensors connected. CO2 sensors connected to the W220. The control will automatically self-enable the DCV functions. May take an hour to self-enable the first time. Why it's so long, God only knows, but it is. If the space CO2 level is below that set point, operation sequence looks like the same as always. Again, if it's over that, then of course it's going to go into operation mode. Checkout mode that we talked about, allows the tech to quickly run the damper controls through a check just to see if it's opening, closing, what's going on. So that's right in your control. Alarms in there. There's plenty of alarms you can set up. It's completely up to you. You don't have to set up any. It just depends on your application. What does your customer want? If economizing is really critical for your location, then you may want to set up some alarms. Maybe there's a flashing light or whatever. It's there. It's there for you to use. Again, I know it's the old joke about the instructions, but especially with when we're talking economizers and setup, it's nice to breeze through that manual and check some things out. It'll help you reconfirm you got the right part numbers, right model number, the application's right, and a few install things. All right. Questions on that? Almost done. Awesome. All right. Variable frequency drives. Everybody loves VFDs, including me. That's a complete lie. But they're out there and we got to have them. Why? You can thank the United States Department of Energy. 2018 made a ruling. It's mandated that all manufacturers must comply. Units built in 2007 can be sold in 2018 and beyond in the US, but we have to increase the IER levels and meet these requirements. So we've integrated this stage air volume standard within these models. And the way that we had to do that was to introduce a variable frequency drive to take a single speed fan and turn it into a 2-speed fan. So first stage cooling, fan low speed, first and second stage, you get fan at 100%. Any heat call, fan at 100%. Just ventilation, you're going to get fan at 66%, which is 40 and 60 hertz, which we all know, you've probably all run into one by now. So they're on any of these units, 4850 LC between those two denominations, the 4850 HC-Q. That's correct. Economizer stop rating under 45 degrees. Unless you have a low ambient, but then that's a little different because then it's going to operate the condensing unit and not the economizer. The question was economizer stop rating under 45 degrees. This is correct. And then, of course, the 4850 TC and KC units have them as well. All right, so we'll go through this a little bit. Yeah, we don't need that. Safety, be careful. Obviously, this is a line voltage powered unit, so don't be sticking your fingers in there unless you have a wish or something. So as we're talking about this, they're always talking about, and we get into parameters. That's where this D1, D2, D3 comes in. It's just a part of the setting. It's going to close terminals 10 to 16. And then we're going to be a safety interlock, deactivate the stop drive. So D1 is not closed. The air will not rotate in auto. If D14 is not closed, the 2021 fault will be posted, which means there's an internal safety error. So it shut itself down because there was an issue. That right there is your friend. If you don't have one, it is highly, highly recommended that you get one, because if you call with an issue, that's my first question. Do you have the control panel or access keypad or whatever? It's got so many names. And if you don't, we're done. Unfortunately, there's nothing that I can help you with. We can check and see if line voltage is coming in. We can check and see if line voltage is going out, but that's about it. One of the biggest things here is you only want to operate this thing through parameters. A lot of times they don't ask you, do you want to use assistant mode? And we never, ever, ever want to use that. We want to select parameters, we want to hit enter, and we want to do this thing manually. Mike, I'm sorry, I can't remember if any of the sales guys are still on. Maybe they can throw that out for us. But obviously, without it, Tom, it has a I can't remember off the top of my head, but it's like CR Disc 002. I can get it for you. I don't remember off the top of my head, but it's got a weird name. But something CR Disc is usually what it's called. Yes, if you have the older version, it will not work on the newer version. So you want the one for the 320 because it'll work on the 550 and the 320. It doesn't do that in reverse. And there it is. CR Disc Kit 001 at 00. Thank you, Don. That was close. So initial power up, obviously we're going to turn the thing on, right? No service factor should be added to the FLA, so we're not worried about any of that. Use the product nameplate. It's determined on the motor plate. In many cases, ready for HVAC blower duty at a current higher than motor plate FLA. So it just means sometimes the parameters may be a little different than what the motor is. So they're talking here about verifying rotation. Hand in this, we see, if you see down on the bottom right, that's basically your manual operation. So that's the first thing you want to try, right? Hit the hand mode, see if the motor runs. If it doesn't, now we got to go into some other things and see what's going on. But again, without this control, you can't even do that. So you're basically just running the wires right to the motor and letting the thing run. So, but again, there's some safeties in there, verifies motor operation, and it does a lot of this, you know, as it's testing. But if you want to make sure and you're just starting it up, hit hand in this thing, check and make sure it's running the right way. And of course, press off because we don't want to leave it in hand. Check current. Obviously, we want to make sure we got the right current to it. Press hand on the control panel again. You know, it's just some basic startup stuff. As long as you have this, a lot of times most guys skip this because they're running the system and it's either running or not running. But it's there if you want it. Drive parameters. The values requiring change are application specific. However, the following parameters are typical of those that may need adjustment. Minimum frequencies, acceleration time, deceleration time, switching frequency. And then if you're getting this from the factory, all of this is done. This is only coming into the fact that when we're replacing one is when you have to get into this. Now, you know, at times we get some from the factory that are just whatever. I guess they fell asleep that day or whatever. So we still want to double check some things and make sure it's working. So I'm going to skip through that because we have more. The VFD fan board. Again, this is just a small control board from the main control, which sends the signal to the VFD to start to operate. So again, we got a Y1 call, and I'll show this in the schematic in a minute, but the K1 and K2 relays are off. K3 is on. You're going to get low speed fan. Once we get a Y2 call, then the K2 and K3 relays are on, and then you're going to get high speed. If you have heating, you're going to get high speed right away. And then if you're just doing fan, you're going to get low speed. And here's that connection. So Y1 and G, we get the same input. So we're going to get that. We're going to get that K4 to open. Sorry. And we're going to get a number 2 or a yellow input to the terminal. and we're going to get a low speed fan at that point. If we have Y2 call at that point, or if we get a heating call, then you're going to get high speed fan. And you can test these right at the terminal. You know, we could send that signal there and see if it works. But again, without that keypad, it really doesn't matter because you don't know if it's truly running low or high because you can't see what it's set up for. So there's the 550. That's the bigger one of the two. If you have, again, if you have a control panel from a 550, it only works on the 550. There's your terminals that you take the front cover off, and that's where your wiring is going to be. Down the bottom of this is your fan motor, your line voltage, and then your controls up on the left-hand side there. Here you go. U1, V1, W1 is power in. U2, V2, W2 is power out. And then, of course, you know, a start enable, factory wired 24 volts. So, and most of this is already jumped out. But again, if you notice, there's that D1, -2, 1, and -3. So those are our fan inputs. So when we're doing our parameters, that's why we're looking at those and making sure they're set where we need them to be. Because otherwise it's just a slave, you know, it gets a signal there and it does whatever it's set up for. So here's the newer version. That's the 320. If you have a keypad from this one, it works on the 550 as well. So obviously that's the better one to get if you don't have one. And the number that Don gave you is the 320 control. So again, terminals 9 through 16 there, some low voltage inputs, just like the other one. Again, same thing, power in, power out, ground, common, factory supplied jumper. So, you know, the terminal itself is powered 24 volts. Start enable, we need that powered all the time. So that stays there. And then factory wire for 24 volt VDC input from fan speed board. So that's 13 and 14 is DC. It's just a duplicate. So let's skip to this one. So again, we showed the 550 before. Same thing here on this 320. The number 5 input is for fan or Y1. It energizes and obviously opens this upper relay, closes the lower relay, and energizes the yellow wire to get you low speed operation. You know, that's 66% or that 40 hertz at that point. Humidizer gets a K3, which again is going to energize, open the upper limit, close the lower relay, and you get high speed. So humidity, you're going to get high speed. Y2, you're going to get high speed. W, you're going to get high speed. There, we talked about that. So there's, again, what I was talking about. So we got this W1 call, energizes K1, goes to high speed, and we get 60 hertz or full speed fan. So we get a G and a Y1. Again, open the upper relay, close the lower one, because we've energized it. Now we get a 40 hertz or 66% fan. And of course, G2 we talked about, so that's going to be high speed. And now we got high speed fan because we have a Y2 call. Humidizer in Y1, same thing. You get a high speed. Even though it's a Y1, because we have the humidizer activated, we're getting high speed fan. Humidizer only, same thing, high speed fan. And then, of course, here's just a wiring breakdown of where that goes. It comes from the unit, hits here, and then it's distributed out through the VFD fan board, and then hits the actual VFD control. So VFDs, we know that they fail, right? We know it's a pain in the neck. The biggest thing to think of is these failures are 90 well, we'll say 90% due to supply voltage. So whatever's going on in the town you're in or the city or wherever, there's issues with the supply voltage. Now, sometimes they fry quickly, sometimes they seem to take 2 or 3 years. There is a way to help keep these from frying so quickly. And that's basically putting in an inline reactor. It's basically just, if you think of some of the residential stuff, we're talking about a power choke. We either do a 3% or 5% inline reactor. We put these reactors right in just before the VFD. So we're getting the power from wherever, right? We've got our incoming power. We're sending it out of that box. We put it through the inline reactor or power choke at this point, and then we're powering the VFD. It has shown to save a lot of these. It's just weird with, we get power imbalances, if you have a bigger city, you got a large demand, so that power balance is going up and down. I have a chart that I have. If you don't know whether to use 3 or 5%, let me know. We'll get some information, what the power line voltages are, and I'll have you put that in and we can look at it. But that inline reactor is huge. Now, Carrier, Bryant, CPD doesn't sell it. So you're going to have to go to, an electrical supply store, or I'm sure there's bought online. I have a few documents that if you're interested in what kind, I can send it out. I got a white paper on it that I can send you. But if you have one fail and it just failed for no reason at all, before you put that replacement in, we got to put that inline reactor in there. It's going to save you a huge headache, and it's going to save you from having to call me or somebody here 50 times, reprogramming them every couple of years. So make sure you're looking at those reactors. And for those of you that are putting them in, maybe you just put it in then. Maybe you just get some and, hey, I'm putting in a rooftop. It's got a VFD. I'm just going to put this reactor on. They have done so much testing that even the ones that come back that seem failed in the field, they power them up at the factory and they're working. So we just got to get those reactors, and we just got to start putting them on these, or it's just going to be a headache from a long time. I think I'm going to read a question here. So with the Danfoss version, and I didn't put that in here, but that's just how, that's part of their software. They don't do a drop down, or they do that drop down to 40%. That's kind of part of their slowdown procedure. I have to get a hold of them and get some more information on it, but I've heard that from a lot of people that, once that heat call satisfied, it slows the blower down to 40 hertz or 66%. So I'll have to get back to you on that, John. All right, so we talked about this, right? Test questions, true or false. All replacement VFD drives come with a keypad. That answer is definitely false. You can order it both ways. You can order it with or without. You got it. The replacement drive from RC does not always come with a keypad, right? Each version has a different part number. That's to make sure the keypad is included. So if you are ordering one, you're making sure you're getting one with the keypad. Now, at times, I'll warn you, if you're replacing one that didn't have it and ordering one with it, sometimes there's a little warranty snafu there. So that's something you have to work out with warranty. Sometimes it goes through, sometimes it doesn't. So that's why we're asking or saying to everybody, if you don't have one, get one. If you work on a commercial unit, once a week or twice a month, you should have one in your tool bag. just because there's plenty of those out there, and that's the last thing you want. You get up there, you get a hold of us, and I say, do you have it? You don't. Sorry about your luck. So good luck with that. If you're calling for parameters and you're calling with help to set up, test question, by the way, I need to know the VFD part number, so the drive number, and we need to know the part number for the motor. Okay, so now these changed a little bit, but a lot of the books that I have the old number and the new number and whatever, so that's not a big deal. So we need the VFD part number, which is that HK30WA, whatever it ends up being. And then you got to know the motor part number. So we got to know if it's an HD 56 FE or FR or whatever. As long as we have that, then we can start to go across the line here and check parameters. I try and if I'm doing it, I'm helping you, I'm trying to do it in order so you can see that the list isn't terribly in order. You don't have to do it in order. It's just, I don't know, I'm weird, and that's how I give it to you. So, so we're going to go through, you check voltage, make sure if we got 460 unit, make sure we're set up for 460. We're doing amps, right? Motor frequencies. Here's that constant speed. So here's your D1, D2, and D3. So D1 is going to be 40 Hertz, D2 is 60, D3 is 60. Again, here, constant speed selection. So we're looking at 1201. We want to make sure that we're looking for 2 and 3 because we don't need to worry about 1. And they only do this because there are some applications to where they can have 3 different speeds here. Carrier doesn't worry about that at this point. They're just doing 40 and 60, or even Brian. So sorry. If I say Carrier a lot, I don't mean anything. It's just how my brain works. And then we'll go through those. So what is that about? Maybe 15 or 16 parameters. And these are the only ones we have to worry about. So as long as we go through and we set these up, you should be ready to go. So, and again, we'll go through the literature there, whether it's a 550 or things, same thing. Need that VFD part number, need that motor part number. And, if you're doing it by yourself, don't assume, right? Make sure you or your tech on site goes through every parameter in that list, because if they skip one, you're going to have a headache, and then we're going to have to go through them all anyway, because I don't know which one they skipped, and they probably won't either. So one deviation causes you an issue. And of course, as I said, the replacement drive does not have the correct data. So you are going to have to do it yourself prior to running the drop. We never want the VFD to be on. So we're going to check that, make sure it's off. And we never want the unit to have a call when we're programming this. All right. Questions, issues? I know they're a pain. But again, use those inline reactors. They're going to be a lifesaver for you. All right. I'm going to breeze through this really quickly. We've gone over it 1,000 times. If you don't know it and you have a question, please stop me. So the website that I showed everybody earlier, all of these videos are on there. So if you haven't messed with this yet and you're about to, they're out there. It tells you about how to take the vane actual fan apart if you're placing a motor, removal, reinstallation of those, whether it's Carrier, the EcoBlue, or the Bryant Axion fan technology, that they both work the same. Those videos are on our site. You can get them on Partners as well. They really did a nice job with that. They're not overly exciting, but they show what you need to do and how to do it. Setup is very simple. We got a couple things that we need to know. First, you're going to put a meter. This is directly on the main board. You're going to put your meter on the VDC terminals. check it to DC. You'll have to have a manometer again, as I said earlier. Make sure you guys have a manometer in their bag. It's a huge thing when we come to commercial. So we're going to have to do a basic ESP. Now, if you had a really good engineer, maybe he already told you what the design was on the building. If you're doing a replacement unit, you're going to have to do an ESP check. Okay. So you have to know that. So once you figure that out, you use this chart. Okay, whatever CFM do you want? If you want 2000 and you got a 1.0 ESP, you go across 2000, it says 9.0. If there's an economizer or electric heat, we add a little bit here. We've got a variable that you add. And then you come back here with your meter hooked up. You turn this potentiometer till it says 9.0 or 9.1 or whatever you end up needing. You look at your selection switch here. All right, I need 9.0, so I have to be in range C, and you are done. That fan is set up for 2000 CFM, and you're rocking and rolling. Now, again, once you get this set up, you're going to want to check that airflow again, just to make sure that, you know, it didn't get way out of whack, or if you have to adjust it. But for the most part, you don't. Question in the test is, can you set this up without knowing the static pressure? The answer is absolutely not. I mean, you could turn that dial all day, but you're never going to know what your airflow is unless you know what your static pressure is. So, you know, you may have to do it a couple of times to really dial it in, but you got to know static pressure. You got to have a manometer. All right, that's it for me. I'm done talking. You're probably done listening. We do appreciate everybody joining us today. I know sometimes these classes can be a bit time consuming, but this was a lot of information and we get a lot of calls on this stuff. So I was hoping everybody enjoyed it. So there is your test link.